Hi class, and welcome to week 5, chapter 5. This week we're going to be talking about factoring. So in section 1 we're going to start talking about factoring numbers, and then we're going to get on to more complicated things later on in the chapter. Okay, so first of all, why would we want to, what is factoring a number? What are we talking about that? Before we talk about factoring numbers, we kind of have to talk a little bit about prime numbers, because that's really what we want when factoring numbers. We want to break down big numbers into their smaller prime numbers. So just recalling from week 1, our prime numbers are numbers like 2, 3, 5, 7, etc. These are numbers that can't be divided by any other number other than themselves and 1. Right? There's nothing that can divide 2 other than 2 and 1. 3, the same thing, 3 and 1. However, most other numbers, or all other numbers, are actually composed of prime numbers. So we can actually, any number that's not a prime number can be represented by multiplying a couple of prime numbers together. Example, 8. 8 is 2 times 2 times 2. So multiplying 2, which is a prime number, 3 times, we get 8. 9 is another number. We can multiply it by 3 times 3, 2 prime numbers. 10 is 2 times 5, etc. We can do that for all other numbers. And that is what we mean when the book talks about prime factorization. So prime factorization is just factoring a number into its prime components. Okay, you'll also see this as breaking it down into its greatest common factor or something along those lines. But when we're factoring numbers, this is what we're talking about. So should be fairly straightforward, but you'll get lots of practice with this in the ALEKS assignments. Okay, now that we've talked about the easy stuff, let's talk about some of the more difficult things like factoring polynomials. Okay, so when we're talking about factoring polynomials, we've got some equation like this, where we've got 5x cubed plus 15x squared. Okay, so maybe this is a little bit more complicated looking than just factoring numbers, but it's actually quite easy. What we want to do is find the greatest common factor in each of these two terms. Okay, what that basically means is that we want to find something that we can divide both of these two terms by. And what we want to do is we actually want to treat numbers and variables separately. It just makes it a little bit easier. Your book sort of always grabs, the answer at once, but I think it's far easier to look at numbers and then the variables separately. So first, let's go ahead and factor the numbers here. So the two numbers that we've got here are 5 and 15. So what do they have in common? There's 5, and 15 is 5 times 3. So we can factor out a 5 out of each one of those terms. Okay, so we just pull out the 5, and we put brackets around the inside stuff. Let's just confirm that that works, and we see that it does work well. So that's basically what we're doing, is we're just dividing out a common number. Great. Now let's factor the variable. Okay, so in this case we've got only a single variable, x, but we've got an x cubed and an x squared, both of which contain x squared, right? X cubed is x times x squared. So we can factor out an x squared here, where we have 5x squared outside of an x plus 3. And then we're done. That's how we factor a polynomial. Very straightforward. It's confusing at first maybe, but you'll get lots of practice with it, but you should see it's very straightforward. You're just finding a number that you can divide both of these terms by. Okay. Obviously, not all things are quite as simple as that previous example. Sometimes we've actually got several different variables in an equation. So what we want to do is actually treat each variable independently. So here's an example we have, where we've got numbers and two different variables, both x and y. Okay, so what's our process for doing this? First, let's factor out a number. Again, step by step. First, we want to factor out the number. Both 7 and 28 can be divided by 7, so we factor out a 7. 7 times 4 is 28, so we keep inside a 4. Good, so all we've done is the number first. Next, let's factor out an x. Both of these terms have an x squared term in them, so we can factor out an x squared, and we're left with this. Finally, we factor out the second variable, y, and this is what we're left with. Now, mind you, this order doesn't actually matter. We could have done this in reverse order or any other order we want. This is just the way that I chose to do it. Number, x, then y. But again, you can do anything. The order doesn't actually matter in this case, but I do recommend doing them separately here. So I hope you're getting an idea for what you'll be doing. It's very easy. It's just dividing, basically. Okay. Now we're going to look at things that are a little bit more complicated. And we're going to talk about FOIL. We're going to multiply polynomials and use the technique called FOIL. I'll show you what that means here in a second. But let's say we've got two binomials like this, where we've got an x plus a times x plus b, something like that. Now, we saw this a little bit in chapter 4, but let's look a little bit more closely at how we multiply this. F stands for first, so we want to multiply the two first terms in our binomial. So in this case, that's x times x, which equals x squared. O stands for the outside. We want to multiply the two outside terms in our binomial, which in this case is x times b, or bx. Usually that b, it doesn't matter how we write that, but that's the sort of common way of doing it. I is inside. We multiply those two inside terms together. In this case, that's a times x. And then we multiply the two last terms of our binomial, which in this case is a times b. And then what we want to do is actually add all of these up, and we're left with x squared plus bx plus ax plus ab. Okay? And now those numbers can be negative numbers. They can be, a can be another variable such as y or something like that. There can actually be a number in front of those x's at the beginning. So it gets more complicated, but right now let's just keep it nice and simple. Okay, so again, we want to factor more polynomials. So we found that term. We saw how to multiply those binomials. It's often very convenient to find a factorization of our polynomials that looks like two binomials multiplied together. When we start solving equations, you'll see why this is nice and convenient, but for now, let's just, we'll try to just factor and get it into this form. Okay, so let's look at an example. We've got an equation, x squared plus 2x minus 3, and we want to factor this. So the usual process, your book has lots of sort of fancy techniques that work for specific cases and sort of require you to know the answer ahead of time. It then talks at the end sort of about a guess and check method. And basically what you're doing is you're going to work FOIL backwards. The reason that I prefer this is that it always works. If it can be factored into two binomials, you'll find it this way. You don't have to rely on any tricks. You just have to remember FOIL and apply some of the rules. Okay, so in this case, we know that our f term is x squared, which is x times x, okay? Which tells us that we have some form that looks like x plus something times x plus something, okay? We don't know anything else at this point, but we know that this is what, if we can factor this as two binomials, this is what it's going to look like. Okay, we don't know what O and I are because all we have is a single central term, right? But what we do know is that O plus I must equal 2x. Right? Look back at some of the previous stuff, and you'll recall that both the O and the I term had a single x value in them. Okay? So that's what we know at this point. Lastly, we know that L equals minus 3. Okay? The negative sign is important here. And what does that tell us? That tells us that our last two terms, the only way we can multiply two numbers and get L is if we multiply negative 1 times 3 or 1 times negative 3. Okay? And that order does actually matter. Okay? So you can't just put in a negative sign. The negative sign has to be associated with one of the numbers. So we have either negative 1 times 3 or 1 times negative 3. Okay? But how do we know which one? So between the two pieces of information that we have, the f term and the L term, we know that we've got two options here. We've got a number like this. We've got this x minus 1 times x plus 3, or we have x plus 1 times x minus 3. Okay, so we've got two options. That's great. So let's check it. How does it work? Now we actually just multiply these out and we see which one works. Okay, so using our FOIL method, trying it for this side over here, we see that we end up with x squared plus 2x minus 3, which is the correct answer. If we use the other example, the other option, we do not get the correct answer. Okay, so, and usually here I'm showing a lot of work, but often you can do this pretty quickly in your head or on a piece of scratch paper and just check which one's the correct answer. So while it looks a little tedious here, you actually become fairly quick at this. So not too bad, but that's sort of a good way to go about these. Okay, good. Last example. Not everything is as simple as the example that we saw in the previous one, where we don't have any number in front of the x, and we've got just numbers and x. Okay, they can get much more complicated, such as something like this, where we've got ax plus 3y minus 3x minus ay. Okay, so how do we do this? It's going to be very difficult to do FOIL in this example. Okay, so sometimes we have to just try a bunch of things and figure out what works. So in this case, what we notice is that there's an ax term here, and there's an ay term over here. So it's often nice to sort of rearrange them either based on the variable or on the number out in front of them, or the letter in this case in front of them. So that's what I've done here. I've just rearranged to get the terms with the a in front over here and with the 3 in front over here. Okay? And then we want to factor a common term out of each one of these. We don't always have to factor for all terms, but in this case we had two terms with an a out in front, so we can factor out an a of those two. And we've got two terms with a y in front here, so we can factor out the 3 out in front of that. We notice here that we've got a y minus x over here and an x minus y over here. Well, if we factor out a negative out of that second term, we actually get the same x minus y in both of the parentheses. Okay? And now, in this case, we've actually got a common x minus y in both of these equations. So that allows us to factor out an x minus y from both of those, and we're left with a nice binomial term like this, x minus y times a minus 3. Okay, so I said last example, kind of lied. Again, it continues to get more complicated from there, so I'm going to run through some more examples here. So using sort of what we did before, in more complicated FOIL, I want to show you another way you can do this using more complicated examples of FOIL. Here we've got an equation, x squared minus 14xy plus 3y squared. Again, we want to remember FOIL. Let's go ahead and try to use our FOIL method this time. Always a good way to start if you think you can. So in this case, we know that f is going to equal, I apologize, I forgot the x's here. It's going to equal 8x squared. So we've got that 8 out in front, which makes things a little bit more complicated, and it tells us that out in front of our x values, we have an 8 times 1 or a 2 times a 4. Right? Those are the two ways that we can multiply two numbers to get 8. Again, we don't know about o or I, but we know that when added, we get minus 14xy. And then for our last term, we know that this is equal to 3 3y squared. So, we can only get a 3 by multiplying 3 times 1. So let's put all this together. We actually get several more options this time. We're actually left with 4 options by putting all the different combinations together. So first option is 8x minus 3y times x minus y. Okay, so where you'll notice that I've got a minus sign here and a minus sign here. Where did that come from? Okay, we know for our last term we must have a positive number out in front. We have to have a positive number out in front of our last term. And that tells us that if we have two numbers being multiplied, either they are both positive or they are both negative. Okay? Hopefully that makes sense to you. If we've got, and at first we generally think they must be both positive. However, let's look at our central term, our O plus I term, where it's actually negative. Okay? So this means that two numbers, when added, will give us a negative number, and those same two numbers, when multiplied, have to give us a positive value. And the only way that that can be the case is if, as we see over here, we have two negative values for our second term. When you're doing more of these, that'll start to make sense to you. Watch the examples, plug them in, try it with the positive values, and see that it doesn't work. Show that you need to have the negative. So practice with this. So here's our first option. Our second option is that we have 8x minus y times x minus 3y. Now notice here, all we did was switch where this was. Now the order actually matters. Before, when we didn't have this 8 out in front, we didn't actually care whether the 3 was on the left or the 1 was on the left. It didn't matter. In this case, order actually matters. Okay, so these two things, even though we have the same numbers, the order does matter. So that's where we get a second option. Next, we've got 2 times 4, or 2 and 4. So we've got 2x minus 3y times 4x minus y. And then we have the other one where we switch the 3 and the y, keeping the 2 and 4 together. So now we've got 4 options. Hopefully you can look back and see where that comes from. Hopefully that'll make a little bit more sense. I'm not going to show you all of them, but I do encourage you to go check all of these examples and show that only this one will work. Okay? So I'll just prove it really quickly. Here's the example that I said was the correct one. We use our FOIL, which is 2x times 4x, which gives us 8x. Oops, that's 8x squared. That should be an 8x squared, sorry. And then we've got our outside term, which is 2x times negative y, which gives us negative 2xy. Our inside term is negative 3y times positive 4x, which gives us negative 12xy. And then our last term, which is negative 3y times negative y, which gives us positive y squared. We add these all up, and we get 8x minus 14xy plus 3y squared, which is exactly the answer that we were looking for. Now, as I say over here, I really do think it's a good idea for you to confirm that those other three values don't work. Show that when you do this, you actually get a unique value, and so go through and check that. Okay, that's all that we have for this week. I'm going to start posting some example problems online. I'm going to work them out in video like this. So while we went over everything quickly, I'm going to work out a bunch of examples in a series of videos later. So hopefully that will, between those examples, and then your ALEKS homework, you'll really get a good grasp for this stuff. So good luck this week, and email me if you have any questions.